Now that we have the car body design completed, let's create an assembly where we can design the front and rear wings in the context of where they will ultimately be mounted on the body. Before we begin modeling any new parts, we need to first save our new F1 car design assembly. To start, we'll create a new part in place. In our case, the material will be the same as the car body, which is polyurethane. This is going to be the front wing. Notice that it puts us into the part modeling environment and that the body is shown in the background for reference. We'll start again by defining the shape of the wing in the side view and borrow geometry from the car body as part of the wing profile. After that, it's just a matter of a 3mm offset for the thickness and a perpendicular line to define the top edge. Trimming can be accomplished by dragging across what we want to remove or by clicking the elements individually. We'll add a dimension and a vertex lock so it cannot change the angle as we define the vertical height of the wing profile. And now, just like before, we'll use the region to symmetrically drag the wing to a full width of 80mm. Remember, the spacebar toggles symmetry. Next, let's define the shape of the outer wing support structure by sketching on the end plane of the wing. We can borrow geometry from background parts or from other geometry in the file. In this case, we'll just offset the edge of the wing for the front of the support. Again, we'll use the click and drag methods to trim the corners together to create a closed region. Adding more dimensions makes it easy to tweak the geometry to the exact size and shape that we want. Because we drew on the same face as the wing, we need to select two regions to create the support structure extrusion. Rounding the edges keeps team members from injury when handling the car, as well as makes it stronger and to look more appealing. There are many options for selecting edges to apply rounds to. One is by selecting the edges of an entire face. To get the geometry to the opposite side, we can simply draw a fence around the support geometry and mirror it about the center plane. Just like we did on the body, let's virtually paint the wing support structures with the same black color. There needs to be a slot in the wing that matches that in the car body. This is for the tether line that the car is attached to during the race to keep it in the race lane. By projecting the edges of the slot onto the XZ plane, we can use that profile geometry to create the slot feature using the same open profile method that we used for creating the slot in the car body. Finally, let's add a keying feature to locate the front wing on the center of the car body. Again, the rectangle by center is the fastest way to draw this geometry. A 3 mm by 3 mm square feature will work nicely to accomplish our goal. We just want to be sure not to extend it so far that it would interfere with the tether line. That completes the design of the wing. As we go back to the assembly, notice that we purposely created the wing to interfere with the car body because we wanted the angled face of the wing to be on the same plane as the angled face of the body. To give the wing a mounting location on the body, we'll simply subtract the front wing part body from the car body using an assembly feature. Now that we have accomplished that task, we can go back into the car body part and make the part more machinable. The keying slot needs to extend through the guide wire slot, and this is an easy task using synchronous technology drag functionality. There will also need to be rounds in the corners of the keying slot for a round cutter to be used to machine it. Finally, for safety reasons, let's slightly round the razor sharp edge of the front of the car. As we return to the assembly, I realize we need to go back into the wing and add geometry. One thing we need to take into consideration is the rounded edges we put in the keying slot. We'll need to round the edges in the wing as well to ensure the two parts fit together without interference. Adding a chamfer will also make it easier to assemble. Rounding the wing's razor-sharp edge is the last step to designing the front wing.